A school administrator will assign each student of a group of N students to one of M classrooms. So N is the total number of students and M is the number of classrooms. If 3 is less than M, is less than 13, is less than N, and I've split those up into two different rows so we can see what's true of the number of students, which is greater than 13, and the number of classrooms has to be between 3 and 13. We want to know, is it possible to assign each of the N students to one of the M classrooms so that each classroom has the same number of students assigned to it? So in a very sneaky way, what they're asking is M a factor of N? So they've presented this in very practical terms, but in a sneaky way, this is actually a very abstractly mathematical question. Another way to say that is N divided by M an integer? Does it divide in evenly? So that's the question we're trying to decide here. Well, statement number 1 tells us that it is possible to assign 3n of the students to the classrooms, to the M classrooms, such that each classroom gets the same number of students in it. So in other words, 3n divided by M is an integer. We're guaranteed of this. Well, of course, it may be true that it worked for M. So for example, suppose N equaled 70 and M equaled 7. Well, then of course, it works to assign the kids equal to a classroom. So the answer is yes. But trouble is, suppose M were divisible by 3. Suppose M, let's say that M is 6 and N is 100. Well, then it's true. Of course, 3n, of course, would be 300. And we'd be able to assign 300 to 6 classrooms evenly with the same number of students in each classroom. That would be 50 in a classroom, which is starting to sound like the public schools. But we cannot assign 100 students to 6 classrooms because 6 does not go evenly into 100. So the answer to this question is no. And because we have different possibilities here, we have some possibilities that lead us to a yes answer and some possibilities that lead us to a no answer, this statement by itself is insufficient. Well, statement number 2. Now they tell us that if we assign 13n students to the M classrooms, you can assign the same number to each classroom. So in other words, 13m over M is an integer. Well, there's only 2 possibilities here. There's either the possibility that M goes evenly into N, so 13 times N over M, which is an integer, or the possibility that it goes evenly into 13. But the trouble is, 13 is a prime number. It has no factors other than itself and 1. And also we know that the number of kids, the number of classrooms is less than 13. So M can't be 13. And so it can't be anything that divides evenly into 13 except for 1, unless there's 1 classroom in which you're putting all the students, but that's not a possibility either. So because M is between 3 and 13, there's no way for 13 over M to be an integer. That means that it has to be true that N over M is an integer. And so this statement does give us enough information to determine that we can give a yes answer to the question, and so this statement is sufficient. Now again, all this stuff about factors and multiples and integers, if this is stuff that is unfamiliar to you, I highly recommend checking out Magoosh.com, which is an online test prep agency. We have several hundred videos to instruct you about math. We also have several hundred videos to instruct you about the verbal side, and it will help you clear this stuff up. In the meantime, we have insufficient for statement number 1, sufficient for statement number 2, and that is answer B.